Hello, fifth graders. Miss Hutchinson here, getting ready to bring you Science Lab from my backyard. This week in the lab, we would have done an activity about groundwater. Does that word sound familiar? I sure hope it does. When we were in the lab last time, we talked about groundwater, but let's review really quickly.
Groundwater is just water underground. The last time we met in the lab, we learned that 1.5% of the water on Earth is fresh water found in groundwater. This is water that soaks into the earth from rain, sprinklers, and bodies of water like rivers and lakes. As you can see in the pictures, the earth below the surface has many different materials, some which water can pass through and some it can't. Today we are going to test 4 different materials to determine which would help the water pass through the fastest.
Now, before we can get started, hopefully you've already pulled up the procedures that I posted to the Google Classroom. It's a Google Doc, so you should be able to find it easily. You can print it out if you'd like, or I don't have a printer at home, so I have it right here on my iPad. Now let's look at the materials you're going to need. You may not have everything, but let's check what you may have and what you might be able to use instead.
Here is the list of all materials needed. If you don't have all 4 testing materials at home but want to test 1 or 2, then you will need fewer plastic cups. You need 1 plastic cup with a hole on the bottom, 1 small plastic cup, and 1 large plastic cup for each material you plan on testing. You will need 1 coffee filter or paper towel for each material you plan on testing, plus 1 more for an additional test at the end. You may not have a 2 tablespoon medicine cup or graduated cylinder at home, so you can use a tablespoon to measure each test material and a 1/4 cup measuring cup for the water. Our test materials are sand, gravel, diatomaceous earth, and soil. You may have none or some of these, just use what you have around the house. Finally, you will need water and a dump bucket.
I know what you're thinking. What is diatomaceous earth? Well, let's take a look at it real fast before we get started.
Diatomaceous earth is an off-white powder that kills bugs with an exoskeleton like bedbugs, ants, and fleas. It cuts through the exoskeleton and dries the bug out. It is not harmful to other animals like birds and mammals. It's used mainly by farmers to keep bugs out of grain storage, to keep animals healthy, and to help keep pests out of crops.
Now there's just one last step before we get started. We're going to need a recording sheet. If you brought your science notebook home, perfect. Continue in that on the next blank page. And if not, any piece of paper will work. Check out my setup so you can try to set up the same way.
As always, at the top of the page, write the title, the date, and mark this as an investigation with a star. Then you need space for a prediction, a data table, and a graph. I've left my prediction blank for now, but you can fill yours in. For the data table, make sure you add a measuring label. If you can measure in milliliters, great. If not, something like tablespoons or teaspoons may be better. Your table doesn't have to be exactly the same, but make sure you have a spot to record data for each test material. Finally, prepare a bar graph to share the results. You can title the side axis as the amount of water passed through. Then along the bottom, label a space for each testing material. Also, be sure to leave space at the end for a 5th bar of data. We'll come back to that later. You can pause the video if you need more time to set up and then start again when you're ready to move on.
Did you make a prediction? I sure did. I think gravel will allow the most water to pass through it because there's so much space between the rocks for the water to flow through. What do you think? Fill it out in your notebook and then we'll get started. Now that we've got our notebook set up and our prediction done, let's go ahead and get started. I've gathered all my materials, some gravel, sand, soil, and here is that diatomaceous earth, that white powder that we're going to use to try out. I've got coffee filters. Here are my cups with the holes in them. You can see it right there. 4 graduated cylinders. You guys should recognize these. My tall cups, short cups if I need them. I don't know if I'll need them. And then my measuring cups. Now you could use a tablespoon instead. Each of these is 2 tablespoons, so you'll just have to do 8 scoops of each material when it's time. And if you don't have a graduated cylinder, you can use a 1/4 cup measuring cup because our 50 milliliters measures right about 1/4 cup. All right, let's get started. All right, so the first step of our procedure is to put a coffee filter in each of the cups with the holes in the bottom. I pre-did it as it's a little windy in my backyard. Now step 2 says to add 4 scoops of a medicine cup of each material, 1 into each cup. Now as I mentioned, this is a 2 tablespoon measuring cup. So if you're using a tablespoon, you'll need 8 total scoops. So let me start with my rocks, filling up all the way to the top. 1, 2, keeping it inside the coffee filter, trying not to let it run to the outside of the coffee filter. 3 and 4. Gravel, ready to go. Let's move on to sand. Same thing, 4 full cups. There's 1. Keeping it inside the coffee filter, trying not to let it go on the outside. 2. Oops, that one's a little full. 3 and 4. Gravel, sand, ready to go. Moving on to soil. 4 scoops, once again. 1, 2, 3, and 4. And that last one is that diatomaceous earth. Here we go, 4 scoops. 1, 2, 3, and oops, there we go, and 4. All right, now my cups are ready. I can move on to the next step. All right, step 3 has us measuring 50 milliliters at a time. I've pre-measured 3, so I could do one more with you. And if you don't have a graduated cylinder, you can always use a 1/4 cup measuring cup. 50 milliliters is basically 1/4 cup. So you can either store it in the small plastic cup if you have to keep reusing the same measuring cup, or I luckily have 4 graduated cylinders. On to step 4. Step 4 has us put each cup in the tall plastic cup. That way, any water that runs through will be collected in the tall cup. All right, and now we're ready to test. The next step is to pour the 50 milliliters over each cup, testing each material. Now, if you're doing more than one at a time, you might want to just do one at a time. I'm going to try and just do all 4 at once and see how it goes. I also have a 30-second timer set up on my iPad so that I know when to pull the cups off. All right, let me pull up my timer. 30 seconds, I'm going to do these 2, then these 2, and when that 30 seconds comes out, I'll remove these 2, then these 2. Ready? Let's do it. Hit start. All right, I know it's a little hard to see. Here's my rock, dripping out pretty nicely actually. Here's my sand, a little slower but more steady. Here's my soil. There's some water down there but not a lot. And my diatomaceous earth. My alarm just went off, so let me turn that off. I'm going to pull these 2 cups out first, put them in my dump bucket. And then these 2 cups out second, and I will also put them in my dump bucket. Whew, good thing it didn't spill. Next we have to measure how much water came out. Nothing came out of my diatomaceous earth cup, so I don't have to measure that one. Here's my soil. I've got a graduated cylinder. And if you don't have a graduated cylinder, a tablespoon should work just fine. I'd say I'm at about 9 milliliters. What do you think? 9, 8? Let me record it. That's my soil, had about 8 milliliters. My diatomaceous earth had no milliliters. Here's my sand. I can measure that one. Pour it back into my graduated cylinder. A bit more from there. Oh, we're closer to about 13, I'd say. Let's record that. And lastly, the water from my gravel cup. gravel let through about 25 milliliters. I'm going to record it and then we'll pause. All right, so just to recap, diatomaceous earth, no milliliters. Soil, about 8 milliliters. Sand, about 13 milliliters. And gravel, 25 milliliters. All right, putting the graph on hold, we're going to do our last test, which is to combine the top two materials that let the most water through to try once together. I've reset up my cups. I don't have my materials yet. My top two materials were gravel and sand. So I'm going to do 2 scoops of gravel and 2 scoops of sand. That's a total of 4 tablespoons for each material. So there's 1 and 2 of my gravel, and now 1 and 2 of my sand. I've already pre-measured my 50 milliliters of water, or a quarter cup, and I'm ready to pour. So let me pull up my timer again, and once I have that ready, I'll pour and we'll do 30 seconds to see what happens. All right, here we go. All right, I know it's tricky to see, but here, let me hold it up for you. Okay, I put the gravel on the bottom and the sand on top. And it's dripping through nicely. We're about halfway through our time. Do you think it'll be more than the gravel alone? More than the sand alone? I don't know. We'll have to wait and find out. A few more seconds. Let's see if any more water can come out. Dripping slowly, but it's still coming out. And there's my timer. All right, so I take this cup out, put it off in my dump bucket, and let's measure how much water came out. Okay, pour it in slowly, slowly. Let's see, what did we get? Right about 20. I'm going to say about 19, maybe 20 milliliters. All right, let's record it. All right, now that all our tests are done and we've collected all of our data in our data chart, I'm going to clean up my materials and move to a less windy spot so we can complete our graph all together.
All right, so the last step is to create our bar graph. Now, I went ahead and kind of filled out a quick one in my science notebook just so I had it, but I've also got my data right here. Now on my big graph, I haven't filled in the measurements for my y-axis yet. I'm thinking, based on the most being 25, I'm gonna go about every 2 milliliters. If your results were a little different, you might wanna go by less amount or a longer amount. It just kind of depends on what your results were. So I'm gonna label every 2 milliliters. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26. And that should be perfect because the most I had from any material was 25 milliliters. All right, so first up I have sand, and if I check my data, sand was at 13 milliliters. So I'm going to find my 13, draw a line right here, and make my bar. I like to write the measurement at the top, that way it's a little easier to read. My bar is not very nice, so let me try and make that a little nicer. That's better, more space. All right, next comes gravel, and gravel had the most, all the way up at 25 milliliters. So I'm gonna go all the way up to the top, find where like 25 would be, and then bring my bar back down. Whew. And again, I like to label at the top so I can read it easily as I'm looking at my graph. Next up is the diatomaceous earth. Now, as you saw, no water came out. So I don't have to make a bar, but I am just gonna put a quick 0 milliliters so that people understand I'm not missing data, I just didn't have any data. All right, next comes soil. Soil, I believe, was at 8 milliliters. So I can count up to my 8, head over this way, and it looks it'll be about this tall for soil. Label my 8 milliliters. And last but not least was our combined final test. We combined gravel and sand, and for that one, about 19 milliliters came out. So I'm gonna measure up to about 19, right about here, and make my bar, and I have my 19 milliliters. So there you see.
All right, as a quick wrap up, turn and tell a family member or an adult what you observed, what you noticed. Did you get the results you were expecting? That's it for this time. Until next time, scientists, stay curious.